In example 2, we didn't have to do any math to construct our cost function. We just had to have an understanding of what those values mean and how they translate over to our function notation. In example 3, we had to do a little bit of work. We had to set up and then solve an equation to get that variable cost. Now in example 4, we're going to be given coordinate pairs, which we need to use to construct our cost function, similar to what we did with the price demand function. We're told that a company can manufacture 48 items per day at a total cost of $6,710.47 and 72 items per day for a total cost of $6,984.57. We're told that cost and production are linearly related, which is important information because that tells us that we're going to construct a cost function C of x is equal to mx plus b, where x is the independent variable. So we need to set up coordinate pairs in the form x, which is demand or units produced, comma c, where c is total cost. To do that in Symbolab, we'll use that command line through again. We'll plug in our x value and its corresponding y value, or total cost value. And then do the same for the second coordinate pair. And hit enter or press go to construct that equation. We'll round those resulting values to about 4 decimal places, resulting in a cost function C of x is equal to 11.4208x plus 6,162.27. Now we want to use Symbolab to evaluate that function at x equals 90, so to find C of 90. Or we could use a calculator, but either way we'll plug in 90 for x, and in this case we would get a value of 7,190.142. And interpreting that information tells us that if the daily output increases to 90 units, then our total daily cost will be the value that we came up with for total cost, but intuitively rounded, since this is about dollars, to $7,190.14.